The unbelievable engineering of the F-22 Raptor. The F-22 Raptor marks the ushering of a new generation of fighter aircraft, one that finds its strength not only in speed, but also in maneuverability and, quite frankly, insane technological advancements. It is the first aircraft capable of advanced stealth in all-weather conditions, sensor fusion from multiple weapon systems, supercruising, and supermaneuverability, all the while, believe it or not, saving on fuel. Thanks to these advancements, the Raptor can fly above enemy aircraft quicker than the speed of sound and remain undetected by both aircraft and ground radar. If the enemy somehow does detect it, the pilot can simply pitch the nose up and climb directly upwards. The Raptor's monstrous twin-jet engines create so much thrust, no existing aircraft would be able to catch up to it. The Raptor, just like its real-life counterpart, can be borderline impossible to detect if the pilot wants to remain hidden. It can easily outmaneuver most modern aircraft, and it was never shot down in service history. Today, we will take a look at the absolutely unbelievable engineering of this beautiful bird, see how it's even possible to design and build a seemingly invincible aircraft, and finally, analyze its capabilities based on testing and examples from real-life combat. The Raptor is simply the United States' answer to the Soviet Union's air superiority in the 80s. Based on intelligence reports of that decade, the Soviet Union was blowing the United States out of the water completely when it came to fighter jets, with the Sukhoi Su-27 and Su-35 and the MiG-29. After a thorough analysis, it was concluded that the United States could not match the Soviets in air-to-air combat if it ever came to that. Therefore, in 1981, the Advanced Tactical Fighter Program was initiated. Its goal was simple: develop a next-generation fighter, one that will counter the emerging threats from the East. Lockheed Martin, the lead designers and manufacturers of the F-22 Raptor, worked together with Boeing and General Dynamics on the project. They submitted the YF-22A, an early prototype of what we now know as the F-22. Northrop and McDonnell Douglas, the other team competing for the project, presented the YF-23. And while both prototypes met and exceeded the requirements set by the Air Force, the YF-23 simply couldn't match the YF-22A in most aspects. Even as a prototype, the YF-22 completely overpowered the F-16 Fighting Falcon, which was the USAF's most advanced fighter aircraft at the time. During the testing phase, it achieved a maximum speed of Mach 2.2, while the F-16 couldn't go faster than Mach 2.05. Thanks to its supercruising capabilities, something that the F-16 doesn't have, the YF-22A achieved a combat range of about 800 miles, which is incredible in comparison to the F-16's range of 339 miles. When you add the amazing stealth technology advancements, which were never seen before, as well as the advanced weapon system sensor fusing and the supermaneuverability, it's obvious that the F-16 simply couldn't compare. Thus, Lockheed Martin wins the race for the Advanced Tactical Fighter project, and it starts the production of the F-22 in 1991. However, the Cold War would end with the collapse of the Soviet Union, and all of a sudden, there would be no more need for a fighter that can outmatch Russian fighters. Therefore, the original order of more than 700 F-22s was reduced to less than 200. Because of this, the ATF project turned out to be a massive financial fiasco, and the Raptor, despite its advantages, was a waste of money for the Americans. Nevertheless, the US Air Force now has a fleet of 183 of the best fighters in history. The Raptor would take its maiden flight in 1997, and in 2005, it would be introduced into the service of the United States Air Force, showing the world the true meaning of the words complete air supremacy. There are primarily four things that make the F-22 superior to every fighter jet in history: its supercruising and supermaneuvering capabilities, its incredible stealth capabilities, and its use of weapon systems. Starting with the first two, in case you didn't know what these terms meant, supercruising is an aircraft's ability to sustain flight at a speed greater than the speed of sound, also known as Mach 1 without using afterburners. Super maneuverability means that an aircraft can execute tactical maneuvers such as avoiding fire, evading enemy aircraft, or getting itself in a position to open fire without using traditional aerodynamic techniques and being limited by traditional aerodynamic designs. So, how does the F-22 supercruise? This fighter uses Pratt & Whitney F-119 twin engines, which produce more thrust than any fighter engines in active service. To make the Raptor as light as possible, titanium alloys and epoxy composites are used, ensuring the best thrust-to-weight ratio of any fighter aircraft. This is extremely important. The thrust-to-weight ratio tells us how much thrust the aircraft produces relative to its own weight when pointed straight up. An aircraft needs to produce enough thrust to overcome gravity in relation to the aircraft's weight in order to take off and maintain flight. Simplified, a thrust-to-weight ratio of 1:1 means that the aircraft can produce enough thrust to maintain speed when flying straight up. At typical combat weight, the F-22 has a thrust-to-weight ratio of 1.25:1, meaning it can lift more than its own weight and actually accelerate, not just maintain speed, when flying straight up. In comparison, Russian aircraft Su-27 and Su-35 that the US Air Force originally wanted to overpower in terms of performance and technology have ratios of 1.07:1 and 1.13:1 respectively. On top of all of that, the Raptor is beautifully aerodynamically designed, meaning that the air offers minimal resistance to the aircraft in flight. When accelerating, the F-22 can, with the use of afterburners, reach a speed of Mach 2.25, which is about 1,500 miles per hour. When the pilot puts the afterburners out, it can continue cruising at Mach 1.82, or about 1,220 miles per hour. Exceeding the speed of sound by that much isn't all that impressive. Far less sophisticated aircraft are capable of achieving and maintaining similar speeds. In fact, the Lockheed SR-71, commonly known as Blackbird, another plane that the Americans built to rival the USSR during the Cold War, can achieve Mach 3.3 and easily outpace the Raptor, despite being more than twice as heavy. However, almost all aircraft need to use afterburners to achieve and maintain those speeds, which means that their fuel consumption goes through the roof when they do that. The F-22's powerful engines, combined with a sleek and light aerodynamic design and low fuel consumption, allow it to cover a far greater area at far greater speeds, reaching targets that would otherwise be unreachable to inferior aircraft, and covering a greater distance in less time, all while burning through less fuel. In practice, this allows for 50% greater employment range for the F-22's air-to-air missiles, and it doubles the employment range for the aircraft's guided air-to-surface missiles, simply known as bombs. The aerodynamics and the performance capabilities granting the F-22 its supercruising power also granted the supermaneuvering power. Simply put, unlike the vast majority of fighters, this aircraft doesn't have to rely on flaps, air brakes, the rudder, or the elevators to maneuver mid-flight. These traditional forms of maneuvering use air resistance, combined with changes in speed, to move the aircraft around. If the speed isn't great enough, then the airflow isn't great enough, and the effects of the airflow on the flaps, the rudder, and other control surfaces won't be powerful enough to control the aircraft. The pilot, in this case, risks stalling. If the speed is too great, the body of the aircraft may not be able to take the stress, and this can cause various malfunctions. The F-22, however, is still extremely maneuverable, even at lower speeds, and the pilot doesn't have to worry about stalling. This is thanks to thrust vectoring, which is the engine's ability to change the direction of the thrust. Most aircraft only have forward thrust, but some, like the F-22, can change the direction of their thrust, allowing them to control the movement of the aircraft even at low speeds, when the air resistance isn't strong enough to move the aircraft. Fun fact, the AV-8B Harrier II, famous for its vertical takeoff and landing capabilities, can achieve vertical takeoff and landing precisely because of vertical thrust. If you're having trouble understanding this, take a look at this example. Compare the aircraft to a bicycle. When you're driving a bicycle and you're getting enough speed, you have no trouble controlling it. As long as the road is empty and the tires are inflated, you're good to go. However, have you tried controlling a bicycle when you're barely moving? It's almost impossible, right? Well, what the F-22 can do is the aircraft equivalent of you not falling down from your bicycle while barely moving. Only instead of using wheels and the strength of your arms and legs to maintain balance, it uses thrust vectoring. This allows F-22 pilots to pull off crazy maneuvers, such as the Cobra maneuver, and avoid enemy fire while getting themselves in a position to fire. These maneuvers would be extremely difficult to pull off without vertical thrust. The other side of the supermaneuverable coin means that even when it's below stall speed, the pilot of an F-22 still has some altitude control and won't lose altitude. The F-22 is the first American fighter with these capabilities, marking the beginning of a new era. Very little is known about the F-22's stealth systems. We do know that its airframe was specifically built for stealth, using continuous surface curvatures and curved vanes, as well as low-key hinges and pilot helmets. The materials used on the aircraft are radar absorbent, meaning that it does not reflect as much radiation as other aircraft, which makes it more difficult to detect. The aircraft itself gives off very little frequency emissions, infrared and acoustic signatures, and it's also not easily visible to the human eye. The lack of infrared signatures, achieved by the cooling systems, makes it very difficult for air-to-air and surface-to-air guided missiles to lock onto the Raptor and open fire effectively. As of 2021, there's been some experimenting with a special surface coating that changes the color of the aircraft, depending on the angle from which it is observed. This doesn't only make it more difficult to spot for the naked eye, but also adds another layer of protection from infrared tracking systems. All in all, it's extremely difficult to get a ping on the Raptor, and even when it is detected by radio waves, these waves are quickly scattered, reflected, diffracted, and absorbed. This grants the Raptor the ability to become invisible in a real-life setting. An Iranian pilot felt this on his own skin in 2013, when he tried to take out an American drone over the Persian Gulf. Piloting an F-4 Phantom II, the pilot never detected an American F-22 coming his way. Iran's 3D radars over the area also didn't catch the Raptor coming. The F-22 escorted the drone to safety, and no fire was exchanged between the Raptor and the Phantom, but it was an impressive show of force, proving that the Raptor can literally appear out of nowhere. The Raptor's weapons bay is primarily designed for air-to-air missiles, both beyond visual range and short-range missiles, while it also hosts a Vulcan 20mm rotary cannon. The missile is launched by opening the bay door, at which point hydraulic arms push the missile out of the aircraft, after which the doors close. All of this takes less than a single second, which is absolutely incredible. For comparison, it takes an indicator light on your modern vehicle about 0.8 seconds to flash. An F-22 can open its weapons bay, launch a missile, and close it quicker than that. This makes it highly improbable that the airplane will be detected while still allowing high-speed missile launching. It's possible to replace the missile carriers with bomb racks, which can carry 2 990-pound or 4 240-pound bombs. And if all that isn't enough to ruin the enemy's day, the F-22 can add an incredible 9,000 kilograms, or 9 metric tons of weapons on the wings. Although that significantly impacts maneuverability and speed, and it also makes the aircraft easier to spot, both by naked eye and with radar. The Raptor is sometimes referred to as the most dangerous fighter in history that never shot down anything other than a balloon. This is technically correct. The F-22 has been in service since 2005, and aside from intercepting and escorting a pair of Russian bombers in Alaska, as well as the aforementioned drone in the Persian Gulf, the aircraft hasn't seen much action. That is, until 2014, when it was deployed in Syria as part of the Operation Inherent Resolve, where it bombed the Islamic State for more than half a year, bombing about 60 different locations. It also provided air support for Kurdish forces, backed by the United States against Russian, Syrian, and Iranian aircraft. In 2017, they bombed opium production sites in Afghanistan. The Raptor had to wait almost 20 years for its first air-to-air engagement, though. On February 4, 2023, it shot down a balloon off the coast of South Carolina. The balloon was allegedly a Chinese spy balloon. The same incident was repeated 2 more times in February, once off the coast of Alaska and once over Yukon. Aside from those engagements, the F-22 regularly engages in surveillance, reconnaissance, and intelligence missions. There are currently 183 F-22s in the world, all of which are in command of the United States Air Force, and it costs more than $36,000 to operate a single F-22 for an hour. which is almost as much as a square foot of real estate in New York. And it's one of the reasons why they might be on their way out of service. Since their introduction in 2005, Raptors were continuously upgraded, and they continue to be the most powerful weapon in the Air Force's arsenal. Despite that, the entire project surrounding the F-22 turned out to be a financial black hole for the United States and the everyday taxpayer, because the Raptor, an aircraft designed specifically to engage Russia's fighters, has never fired a single shot towards the east, nor did it ever come close to full battle utilization in other engagements. General Clinton S. Highnote of the United States Air Force announced that the F-22 will likely be phased out from the Air Force, alongside with the F-16 around 2030. Like a self-fulfilling prophecy, thanks to the era of technologically superpowered aircraft that they personally ushered in, the F-22 will be replaced by the F-35, the F-15EX, and the family of systems called the Next Generation Air Dominance, or the NGAD. The small fleet of F-22s won't be completely gone, but it will take a back seat, allowing a new generation to take charge.